This video is about learning outcome number 5, which is all about coefficients of variation. Our goal for learning outcome number 5 is to be able to use coefficients of variation to compare some sample variations when it's appropriate to do so. So here's my first point. We should only compare sample standard deviations when the sample means are approximately the same. Otherwise, it doesn't make sense to compare those sample standard deviations. In that case, we should compare something else, which is called the coefficient of variation. So if we're trying to compare samples that have very different means, or samples or populations that are using different scales or units, it makes sense to use what are called coefficients of variation instead. So the coefficient of variation for a set of non-negative sample or population data expressed as a percent describes the standard deviation relative to the mean, and it's given by the following. So you just take that sample standard deviation and you divide by the sample mean, and then you multiply by 100% to give us that coefficient of variation as a percentage. Of course, we use pretty much the same formula when we're dealing with population parameters. So we would use the population standard deviation and divide by the population mean and multiply by 100% to get that coefficient of variation if we're dealing with population data. And our round off rule for this is to round to 1 decimal place. So here's an example. Suppose the heights and weights of a sample of men were collected, and then the mean height was given to be 68.34 inches, and the sample standard deviation for the height was 3.02 inches. The mean weight for the men was given to be 172.55 pounds, and the sample standard deviation for the weights was 26.33 pounds. We might be interested in the difference between the variation in the heights and the weights. And I would encourage you to think just intuitively. Do you think heights tend to vary more than weights when you're talking about men? Or vice versa, do weights tend to vary more than heights? Well, what we're going to do is we're going to compare those standard deviations relative to their means, multiply 100%, and that's going to give us coefficients of variation. We can compare those two percentages to see whether heights vary more than weights or the other way around. So first, let's compute the coefficient of variation for the heights. We're going to take the sample standard deviation for the heights, which is 3.02 inches, and then we'll divide by the mean height of that sample of men, which was 68.34 inches. If we create that ratio and then we multiply by 100%, we see that the coefficient of variation for the heights is about 4.42%. Now let's do the same thing for the weights. The sample standard deviation for the weights was 26.33 pounds, and the sample mean for the weights of these men was 172.55 pounds. So we take that proportion, we multiply by 100%, and we get a 15% approximately coefficient of variation for the weights. So I think this agrees with my intuition at least. Men's weights tend to vary much more than their heights do. The coefficient of variation says they vary by about 4.4% relative to that sample mean. And while the weights vary by about 15% relative to that sample mean of the weights. So we'll say that weight varies more than height, or that height vary less than weights. And that is how we use coefficient of variation to compare two sets of data. When you look at this data and you say you want to compare the variation of something measured in inches to the variation of something measured in pounds, because we're dealing with inches and pounds, it's like comparing apples and oranges. You might say, how can you do that? How is it even possible to compare them? Coefficient of variation will allow you to compare them.